question.
Then you read this one. You read the quiz form.
Which has greater value, a Newton of gold on Earth or Newton of gold on the moon?
So there are three answers provided. Newton of gold on the earth has a greater value. Newton of gold on the moon has a greater value. The value is the same. Okay, right. Now, this question can be treated in two ways. Using quantitative treatment, that means I actually calculate the value of the Newton of gold on the earth. I calculate the value of the gold on the surface of the moon. Right? One method is to use the calculation. Another method will be a qualitative treatment. Qualitative treatment means I just reason it out, reason with you, right? I just reason. Which one is more acceptable? Which one is? Never mind. So we try the mathematical method, the qualitative treatment method first lah, because that one is sure to be correct one, right? We try. Now, 1 Newton of gold on Earth. You see, this Newton, you know how they measure the Newton? They use the spring balance. There's a balance with a spring inside. Then you hang something at the bottom of the hook. Then you hang it there. Then it will stretch the spring, and from the reading there, 1 Newton. So that is 1 Newton of gold on the surface of the Earth, right? Using the spring, the pull on the spring there. But this pull on the spring there, it depends on the gravitation one. Right? No? The pull on the spring depends on the gravitation. On the Earth, the pull is very much bigger. We see that the gravitation is 9.8. Then on the moon, is very small, 1.62. Right? On the Earth, it's much bigger. The gravitational pull is much bigger. So we can argue it out using reasoning, but reasoning one, we keep it later on. Now we try the mathematical proof. Okay, right. 1 Newton on the earth is actually mg, the mass multiplied with the gravity on the earth. So I bring the g over, so the mass is actually 1 Newton divided by the g on the earth. So 1 Newton divided by 9.8 meter per second square. And I found out the mass of gold is 0.12 kg. So in order to produce 1 Newton on Earth, you need 0.12 kg. That is from our calculation. Okay, now we go to the moon. We go to the moon. 1 Newton on the moon is actually the mass times gravity also. The gravity on the moon lah. Then what is the mass? The mass is actually 1 divided by the gravitational pull of the moon, the g on the moon. And it's 1 Newton divided by the number here, 1.62. 1.62 meter per second square. And we found out the mass to be 0.67 kilogram. What can you say? What can you say? What can you conclude from our calculation?
Calculation: the gold on moon has greater value.
The gold on the moon has a greater value. That is correct. Because if you see the mass here, right? The mass of the gold on the moon is 0.6 kilogram. the mass of 1 Newton of gold on Earth is only 0.12 kilogram. So 0.6 kilogram of gold is more valuable than 0.12 kilogram of gold, right? So the answer is 1 Newton of gold on moon has a greater value than 1 Newton of gold on the earth. Okay. Now we are going to use qualitative treatment. Qualitative treatment means we are going to use logical reasoning. Okay. So you consider, let me see, let's say on earth, I draw here. Bang, 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 and here. So this is the spring, and here. Here, there's a pointer here. The pointer say 1 Newton. Okay. Then we also have a spring balance on the moon, bang, bang. Then carry a weight here. The weight here says, the pointer here says 1 Newton. Okay. Okay. How to reason it out? How to reason it out? Now, the gravitational attraction on the moon is very small. It's very small. Okay or not? In order to produce 1 Newton, you have to put a heavy weight there, a very heavy weight to produce 1 Newton. Now, on the surface of the Earth, the gravitational pull is very strong. You only need to put a very small weight there, it will produce a very big Newton. Okay, not? Because the gravitational pull on the moon is small, you need a bigger mass to pull it down. Because the gravitational pull on the earth is very strong, you only need a small mass to pull it down. So if the two of them pull down by 1 Newton, here also pull down by 1 Newton, here you need a very big mass to pull them down. Here, because the gravitational attraction is very strong, so you need a very small mass to pull it down. So in other words, here you need a bigger mass, here you need a smaller mass to produce 1 Newton. So when you compare a smaller mass and a bigger mass, definitely this amount of gold is more valuable than this amount of gold here. So this is the qualitative treatment, right? You just argue it out because of the weaker gravitational pull and the stronger gravitational pull. Right? Any questions? No, then we are going to end here. But before that,